So, why do we need statistics for AP Psych? It may seem irrelevant, but in fact, 8 to 12% of the AP test is data analysis. So with that out of the way, let's talk about stats. We'll start with centers. There's mean, median, and mode. You've definitely heard of these before. So mean's the average, median's the middle number in the data, and mode is the number repeated the most. So let's say we want to find the center of this set of data. Pause now before the answers show up. And so the answers are 2, 1, and 1. And so what we can take away from this is that the mean is less resistant to outliers such as 7 in this dataset, and the median is a better measure of center when there are outliers like. Moving on, let's take a look at measures of spread. Range, which is 7 in this dataset, is the highest number minus the lowest number. It is not resistant to outliers. The standard deviation, which you won't need to solve in the AP Psych test, is a standardized measure of how spread out data is. Now, things get interesting once we start graphing our data. Skewed graphs are graphs that look like they're skewed one way or another, but the direction of a skewed graph actually depends on the data. With skewed graphs, make sure to remember to use resistant values. Now, the type of graph you'll see the most often in AP Psych is the normal or bell curve. What's kind of confusing is that there are 3 different types of numbers that are associated with the bell curve, and those are percentages, actual values, and z-scores. So beginning with percentages are the percent of data under a certain area of the curve, and some numbers you'll unfortunately just have to remember are 2, 14, 34, 34, 14, 2. And percentile ranks are the percent of data to the left of a certain point on the curve. Now, the actual values and z-scores on the bell curve are actually kind of related, so I'll explain them together. Z-scores are how many standard deviations a certain point is away from a curve, while actual values, which are kind of self-explanatory, are the actual values of the data points. For example, this point has a z-score of 1.5 standard deviations above the mean, but because the standard deviation could equal 30 and the mean could equal 100, the actual value of the point could be 145. Finally, linear relationships result from graphs of data with 2 numerical values, usually experiment. And with experiments, of course, we can't forget variables. There's the independent or explanatory variable on the x-axis, and the dependent response variable on the y-axis. And ultimately, experiments are trying to prove correlation between 2 variables. There's the correlation coefficient, which tells you direction and strength. It ranges from -1 to +1. A negative r means a negative slope, and a positive r means a positive slope. The larger the r, the stronger the correlation.